That one would think.
I think it's gonna be.
All right, y'all, let us learn. Okay. Okay, so let's finish this dude right here, which we left off like we did part A and B yesterday. We got to do C and D, and then we got to get through. I'm hoping to get through the graphing of polar coordinates. So you actually won't see much calculus of polar coordinates today, which is good. It's like a reminder of how polar coordinates work. But okay, first let's finish this. So watch this. Well, first get reacquainted. It said a particle moves, blah, 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 blah. It gave us the derivative of the x function, the derivative of the y function, and the original of the position function. Then it says t equals 4. This was its position. It says find the y coordinate of the particle's position at t equals 6, which we kind of already talked, or Kian asked about it yesterday, but I don't know if everybody was listening. So let's review what we got to do. So particle's position at t equals 6. Here's the part. It says the particle's position is this. So if it just wants the y coordinate of it, do you agree that it just needs y of 6? Okay. So it's asking for y of 6. Let me not scroll back and forth. So let me set up the work here, and then we'll do it in the other page. So I need y of 6. I did not get y of whatever. I didn't get y of t. Otherwise, I'd just plug in 6 into that. But I did get the derivative of y. Okay, all right. So then I got to find y of 6 given y prime of 6. Yeah? Does that sound like something you've done before? Like, how would I set this up? Antiderivative for sure you need. Yeah, the integral of this, dude. Yeah, that's the thing. Anytime you're asked for, give me y of 6 given y prime, then you have to do the thing where you take the initial position, which the one they told you was at 4, to take y of 4 plus the integral from 4 to 6.
We don't know why.
We do know y of 4 is just hidden on there. It says that time t equals 4, the particles at this point. So at the y coordinate would be 5. Yeah, so what I'm about to do on the other page is this exact thing. Just let me leave the setup up here. So let me scroll down. What did we say? It was 5 plus integral of that. Okay, remind me if I forget when I get to the page. So part C, we said y of 6 equals 5 plus integral from 4 to 6 of natural log of 2 plus t squared. That exactly right. Okay, cool. Nice. And then that one for sure you can't do by hand. Like there is no antiderivative of this. So you put it in your calculator or you put it in decimals and you would get integral 4 to 6. Oh, let me do the 5 plus before I forget. 5 plus integral 5 to 4 to 6 natural log of 2 plus t squared. Nice. So this position was 11.5705. Boom. And then part B says, let me not scroll back up. It says, find the total distance a particle travels along blah, 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 from 4 to 6. That's, you rejoice when you read that because that's just like they're checking if you can type the right thing into decimals, basically. Because total distance is just like, you just got to remember the formula. So you should remember, oh, total distance from 4 to 6 is some integral, but what goes in here? The absolute value of b of t, so not just b of t. Nice. And then the new thing for this section is that absolute value of, well, b of t is a vector because it's got an x component and a y component. So b of t is like this function square root comma natural log. That's the vector of the velocity too. So don't take 2 of them because absolute value means, yeah, exactly, the magnitude. Yeah, there it is. I wrote it. Magnitude of this of the velocity function, which was the square root of x component squared plus y component squared. That's really just one big ugly integral, but actually that should look kind of familiar. Boom. And then the x component squared would be this plus y component squared. As ugly and like weird as it, oh, I guess I don't need, well, I do need Desmos. As ugly as that looks, weird as it feels, that's the right way to do it. And then if you do put this into Desmos, there, yeah. All right, put that into Desmos and you get, or your calculator. What am I doing? Okay, in 4 to 6 square root of this stuff squared plus and you get 12.13 if I type that in wrong or right, but let me check that that's what, yeah, I do. All right, 12.136. Cool. It's fine. It's fine. 136 is all you need. If you went 3 places, you're good. On the test. Yes, Kian.
The only reason why there's no like absolute value inside the spectrum magnitude function is that it's reduced square, I guess.
Yeah, actually, the absolute value of something. Sometimes you'll see, like the textbook. Sometimes you'll see it defined as absolute value of x. Just like for normal numbers, is just square the x and then take the square root again, and then that'll make it for sure positive. Yeah. No. All right. One conceptual question for you guys. This, you guys remember how like 2 or 3 days ago we said that this was the this exact formula was the arc length of the curve. Yeah, you may or may not remember that. Okay, but why does that make sense that we're finding the arc length of the curve from 4 to 6, and that gives me the total distance that the thing traveled?
It's a lot.
Yeah, it's like you're finding the total. Here's the position curve that it followed, whatever it looks like. It might look something like this. Let me just make it crazy. Okay, if it looks something like that, I get asked what's the total distance that it traveled. Well, it just traveled however long this curve is. Nice. So there's 2 ways to think about it. Either think of it as take the absolute value of the velocity function, just like I'm used to with normal rectilinear, like straight line motion. And that would be the magnitude of the velocity. So this, or you can think of it like, okay, let me get the length of the curve, the position curve, which is also the same thing. Cool. Good job, you guys. Hopefully that makes some sense. I wanted to say one more thing, but I've forgotten it.
Wouldn't the length, like if you're tracing the length, right? Why would you use triangles like Pythagorean theorem to figure that out?
Because hey, nice. Because you're splitting it into. I kind of didn't go into detail of this in the past, but I said here really quick. I might, but okay, let me try to copy that. Okay, there. What you do is you're like, oh, those are curved lines. Those are, I don't know how to take the length of that. But what you do, like, let me zoom out, give you a big picture idea of what you do is you split it into tiny, tiny intervals where it's like, it's basically straight there. So you take straight line distance here, straight line distance here, straight line distance here. And then you make it tinier and tinier intervals. And that's like the result. Nice. Oh, and those straight line, obviously, you get the distance. Nice, y'all. All right. Cool. I thought maybe it might be good idea, because you've never seen these before. Let me pull up the scoring guidelines for this. So you see what they look for on the test, like what you should write, what you shouldn't write, etc. So when was this from? 2022. DC, I've already helped you with. Right back. Okay. All right, let us find it. This one, 450. That's not it. This one, particle moves. Yeah, here it is. Okay, so the first one. First of all, notice we did it right. Good job. Second of all, notice you could have put here. All right. First one, they were looking for this answer. They said, and it's worth 1 point. I didn't want to scroll there. It was worth 1 point, and they would have taken either the decimal or the thing, the like fraction. And it said to earn the point. You can put any of these forms. Look at. This is the thing I keep telling you guys about. Like they really care about the way you write your stuff. Like if you had put y prime of t over x prime of t equals number, because you have t's here and not 4's there, they would be like, no point for that one. So just avoid these little equal signs. If you're ever not sure, write y prime of t over x prime of t, and then write a little arrow to this or whatever. Because they hate when you compare two things that are not equal. Like they really check for like if you wrote, like if your work is mathematically precise. So be careful about that. This way I'm showing you these. Yeah.
So that, like, if you were to answer just y prime of 4 over x prime of 4, you have to actually solve it about that thing.
Looks like it, yeah.
That seems to like this quickest thing. You like already have plugged in.
But then Desmos would tell you that's 0.701 at least.
Yeah. So you could just do that.
Yeah. You can leave it here, you can leave it here, you could leave it here is what they're saying. Yeah, any of those get the point. Nice. Okay, good. I'm glad you guys are getting something out of it. All right, watch this. Next one. That part B, find the speed. Is that what it says?
Yeah.
Okay. Then it says. Oh yeah, there were two parts. There were find the speed, that was 1 point. I was just like put in this equation, and then there was the acceleration, that was 2 points. Oh, that was pretty nice. They gave you a point for each, like the XY part and the Y part. I don't think I have much to say about that other than like, here's the different forms you may have put it in. Let's see what they said in the little notes. During the first, any of these points, the setup to perform the calculation must be evident in the response. Right, so I guess if you just put the answer, they don't like that. So they want you to show your work. Second and third points can be earned independently, meaning even if you don't get the first part right, you can get the second and third. Acceleration vector is not presented as an ordered pair. The x and y components must be labeled. As in, you could have not put like a comma between them, but you could have put x prime of 4 equals this, y double prime of 4 equals this separately, and they would have taken that apparently. If the components of the acceleration are reversed, you don't get any of the points. So had you put the y part first, y comma x, they don't get the points. Response which correctly calculates the expressions for both y x double prime and y double prime, but fails to evaluate at 4, only earns one of the two. So that's actually pretty kind of them. If you got these derivatives right, but you didn't plug in 4, they still give you one of the 2 points. And then an unsupported acceleration vector earns only 1. As in, if you had just typed it into Desmos and given the answer, you get 1 of the 2 points. Yes.
To your team. equal 18, is that okay? if it's
Yes,
not
that would have been
either?
fine. Yeah, no simplifying. Simplifying is never, ever, ever absolutely required. So what we have. All right, cool. Let's go quickly through the rest of the. Hopefully you're getting something out of this. Y coordinate of position. It says do this. Oh my God, look at 3 points for doing one thing basically, which is nice. Here's what they have as like the model answer. So let's see what they absolutely needed. For the first point, an integrand of this can appear in either indefinite integral or the correct definite integral. Oh, wait. For the first point, an integrand of this, as long as you have like this in an integral, they give you a point. So whether you put it as indefinite, like you didn't do 4 to 6, or you do like 0 to 6, they still give you a point just for having this in an integral. Kind of nice. A definite integral with incorrect limits is not eligible for the answer point, so you could only get, I guess, 1 point or 2 points. Similarly, an indefinite integral is not eligible for the answer point, so you just get the setup point, but not the answer point. For the second point, the value of y4 must be added, so you get 2 points just for having y4 plus some sort of integral of this natural log function, and then a response that reports the correct x coordinate instead of the y coordinates earns 2 out of the 3 points. Oh, interesting. For whatever reason, you got the x coordinate instead of the y coordinate. You got 2 and 3. Okay, and then the last one. I think, oh, this is the one that's dying. Or it's later. Oh my God, look at all these notes. I don't know that these are worth reading. A response that earns the first point but not the second can earn the third with an answer of that. Okay. I'm not super sure what that means, but I think the second point was about adding y4. So if you just showed on your paper 4 to 6, natural log of whatever, and then you ended up with this answer in the end, you'd get 2 of the 3 points, which is good. If the differential is missing, oh my God, look at this is the type of thing I'm talking about. Look at if you don't put dt, then you only get 2 points. If you forget the dt, that's kind of mean. But they're kind of weird because there's some they're very generous with points in some sections, but really stingy with points on other sections. So be careful about that. Just be really they really love the notation. They're all about like you writing precise notation. So dt, the dt, and then this earns the first 2 points. Oh wait, maybe I'm wrong.
We're talking about the y.
So not in the first, but oh yeah. Okay, so I'm wrong. Look at this does get you 3 points. If you don't put the dt. But the thing is, if you don't put the dt and you put the y4 after, then it looks like this y4 is within the integral, which is why this one would only get you 2 points. This one was only 2 points because you don't have the y4, and then this one is all good. If you forget the dt in this format, then there's no ambiguity whether you meant the y4 is in the integral or out of the integral. So you get all 3. That's my bad. Good job catching that, Kian. So, no, I really don't. I think you'd be fine. Okay, and then what's the last thing? Oh yeah, the total distance. 2 points for that. 1 for the like just that you have the right thing inside the integral, and then 1 for the right answer. First point is earned for presenting the correct integrand, like the thing inside the integral. The second point, response must earn the first point and must present the value of 12 point something. An unsupported answer of 12 point something. Wow, if you just put 12 point something straight up without writing what you put in the calculator, you don't get any point.
Oh.
So what we learned out of this, be precise with your notation and put your, like, write your work, like, as you put it into the computer. Cool. All right. Well, I'm glad we took the time to do this. I should do this with the AB as well sometime. I'll probably do it Wednesday. Okay. Now let us review 824. Okay. Yeah, this is good. This is good. We'll see how far we get in polar coordinates, but we might have to come in Friday. I had planned 3 days just in case. let's see how far we get though. Polar coordinates. Maybe we go faster than I thought because you guys saw these last year as well. So you might just need a quick reminder. But polar coordinates are the ones that, well, let me see if there's anything I need to read from the little paragraph, but I don't think so. It says Euclidean such a system rectangular coordinates are the ones you're used to, like x comma y. But there's other ways of expressing the same points. One of them called polar coordinates. And polar coordinates axis is referred to the pole, the polar axis. You got a theta, you got an r. You've seen this before, so I don't think I'll read that to you. But the idea is that, remember, like instead of describing how to get from me to Nick, instead of saying take steps to the right and 3 steps towards the back of the room, which would be x comma y, you say, okay, rotate 45 degrees and walk 7 meters or whatever. That's the idea behind polar coordinates. So in the image shown, the coordinate point is 4 comma pi over 4. That means start here, rotate pi over 4, did it, and now like go 4 radii towards the in case you forgot. So first, let's just plot a bunch of polar points. 3 comma pi over 6, obviously pi over 6 is how much you rotate, 3 is how many circles you could walk towards that angle. So pi over 6, look at, I'm pretty sure this is pi over 6, they didn't label it, but that's pi over 6, pi over 4 is missing. So that would be pi over 4, this would be 2 pi over 6, which is pi over 3, this would be pi over 2. So pi over 4 is missing is what I'm saying, so be careful about that. And so 3 comma pi over 6 would mean go to the pi over 6 angle and then go put a dot on the 3rd circle on that. In other words, go 3 radii. Boop. There's dot A. That's that one. Then dot B would be 4 comma pi, meaning go to pi, boop, 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 and then put a dot on the 4th radius. This one's B. Done. This one is C, 3 comma negative 5 pi over 6. Just let me make sure you know. Okay, yeah. Yeah, instead of going this way, you'd rotate this way, 5 pi over 6. So that would be 1, 2, 3, 4, 5 pi over 6. And it was 3, 1, 2, 3 for the radius. And then this one's the only one that I don't know if you'll remember super good. But it says negative 2 comma 3 pi over 2. Nice. Okay, good job. Yeah. So go to 3 pi over 2, boop, here it is. And then instead of going towards it, go away from it because it was a negative radius. So don't go down 2 radii towards the angle, go directly away 1, 2. This would be P as in dog.
Or can we just go 2 to the left and go to the
Yeah.
Oh, I see. You guys are doing the radii first? Yeah, with okay, I mean, yeah.
Because that would be negative 2.
Oh, I see. Yeah, I guess that works too. Nice.
You got over though.
Right. Nice. All right. Well, do it whatever way you like it. To me, what I said makes more sense, but whatever you think. All right. There's plotting points. You guys remember a lot more than I thought. Good job. We can also convert polar coordinates and rectangular coordinates using the power of friendship. So it's change the point. Oh, I wanted to change this. I wanted to make this because 2 pi doesn't show you really why it works. Let me do 2 comma pi over 6. Just so you remember why it's all works. So the point 2 comma pi over 6 we just agreed was right here. Where this was pi over 6, this angle theta that I wrote is pi over 6. Actually, let me just write pi over 6 then. Okay, and then if I'm trying to make that, if I'm trying to put that in terms of x comma y, then I need to figure out how far did I go over and how far did I go up. In other words, to make that little right triangle, you know that this is 2 because that's the radius of the little circle. And then you use trigonometry to figure out the rest. Right. Well, once you have one of the legs. But that requires two sides and I have one side. But I have a side and an angle, so that would be trigonometry, and then you can use I got your
Yeah.
one. Yeah, but I think it's just easier to describe and more useful to describe this in terms of trigonometry. So what I mean is, if I'm trying to figure out the x and the y, well, the x would just be adjacent over hypotenuse cosine. So cosine of pi over 6 would be x over 2, meaning that x would be 2 cosine pi over 6, whatever that is. And then y, similarly, you can guess it's going to be 2 times sine pi over 6. Hey, hey. I don't, do you know your grade? Oh, you already put it. Yeah. Yes. No, no.
Thank you so much.
No worries. Cool. All right, there you go. And then if you were to actually calculate this, this would be cosine of pi over 6 is radical 3 over 2. So 2 times radical 3 over 2 is the square root of 3. And then this one would be 2 times 1/2, which is 1. So the point would be square root of 3. That too fast, or do you remember? That sounds like I don't know. Oh, okay. All right. Yeah, just look at this little triangle. This becomes a geometry problem. Adjacent over hypotenuse is x over 2, meaning just x would be multiplied by 2 over 7. Okay. Yeah.
So it's really just unit circles and multiplied by whatever the radius value.
Yeah, that's exactly it. Yeah, and in fact, we're about to use that in a second. So really, really important for this whole section, even for like the calculus parts, is that x is always going to be what Kian just said, r times the cosine of theta, like the unit circle, and y is always going to be, I should make this like color. And y is always going to be y equals r times sine of theta. You'll use that a decent amount anytime you take a derivative or a integral. Nice. Okay. So then it says none of this will you get asked for the calculus part of the test, but it's all kind of helpful to help you understand the full report. So next part says express the following whole function. This whole function, express that as x comma y, like as y equals something, right? And so the idea for this, did you do this last year or no? You remember how the strategy is? Yeah. Yeah, I mean, the strategy is basically try to get this or this in there somehow. So like what I see is r equals 3 times cosine theta. If I multiply by r on both sides, then I get 3r cosine theta, and r cosine theta is x. So like the strategy is insert this into the equation any way you can, and convert everything you can. So what I mean is what? Well, let me say that in a second. All right, so watch this. Here's what I mean. Let me multiply by r because I want to multiply by r here, multiply by r here. That again, the motivation is that I want 3r cosine theta. R cosine theta is theta. Okay, so then I will get r squared on one side equals 3r cosine theta on the other side. And the r cosine theta is exactly what I just said. I get r squared equals 3x. And then you've actually kind of done it already, because the third thing that I should have said up here is that I don't know how much detail to show, but let me do it off to the side. We all agree that sine squared of x plus, or theta, whatever, sine squared of theta plus cosine squared of theta is equal to 1. Okay, so then watch this. If I had put r squareds in here, if it had been r times sine of theta and I squared that. Anyway, if I get r squared sine theta times r squared cosine of theta, I would get r squared here. And this is just the same thing as this. And last thing is that we just agreed that our sine of theta was y, and this is x. So y squared plus x squared is r squared. I don't know if you remember that from last year, but that's another helpful tip. And so this r squared, you can replace with x squared plus y squared. And then express the following equivalent in rectangular form. There, I have no thetas, I have no r's, so you could circle it and be done. And if you're ever trying to verify, like, did I do this right? You can go to Desmos, watch this. You can go away, I don't need these anymore. But look at Desmos does polar functions. If you type r equals 3 cosine of theta, and theta you can find probably on the keyboard somewhere, but if you just type in the word theta, Theta, it turns it into theta. All right, so there's what the function looks like. R equals 3 cosine theta. Let me make sure we converted it right. X squared plus y squared equals 3x. And I get the same thing, so I know we did it. Nice. Cool. All right, next one, 9 minutes. Okay, we didn't get as far as I wanted. But okay, next one, same idea. R equals 2 times cosecant of theta. Rats, I see a cosecant in there. My strategy is get R cosine and R sine. So if you guys have any ideas what I could do? Yeah, exactly. Just like make it the identity. R, get it in terms of sines and cosines, and then see how you can get one of these. So R equals 2 times 1 over sine. So let me write that as 2 over sine of theta. And then again, goal is to get R sine of theta or R cosine of theta. You see a way to do that right now without introducing. Yeah, okay, yeah, you may have seen something different than me. But I think the easiest thing is get this sign over here, then you get R sine of theta equals 2 straight up. There you go, and R sine of theta is just y equals 2. This crazy looking polar function is just apparently a straight line. Let me make sure we did that right. I go to Desmos. I type it, well, first I IT. Then I say R equals 2 cosecant of theta. Boom, straight line. Y equals 2. Boom, straight line in the same place. So we did it right. Nice. And then is the next thing graphing functions? Yeah, which we don't have time for in 7. Yeah, sometimes because like, yeah, you don't have to. Sometimes it's too much, and it's impossible to get y equal. I think in both of these cases you'd be fine, but sometimes you can't. All right, good job. Tomorrow we'll graph the thing, we'll graph the function, and that's a big helpful thing because eventually, look at tomorrow we do these, boom, 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 and then we take that is just like helpful things to know, and then we start taking derivatives. And then areas inside graph, which is helpful to know the function, the length of the graph. It's integrals. Yeah, when polar coordinates. Yeah. Integrals with polar coordinates. Yeah, and they're kind of. Yeah, those are they take a lot of brain, or at least for me.